Okay, we're on Chapter 2, Section 3. The first topic in this section is biconditionals. And if you take a look, first thing I want you to notice is that the symbol for the biconditional is a double-sided arrow because it is reversible. And so if you take a look here, it's read P if and only if Q. Okay? I also want you to notice if you read through the example, take a second and do that and then restart the video. Okay, if you read through the example, you'll notice that we don't lead with the word if. There is no then happening in this sentence, okay? So when you write a biconditional, don't use if or then. Okay, keep that in mind as we move through. All right, we're going to move on to the examples on the next pages. Okay, we're on page 2 of the biconditionals handout, and you'll see that we're going to read that statement. We're going to decide if it's reversible. And again, to be reversible, we need the original statement, the conditional, and its converse to be true. Okay, so if a whole number is a multiple of 2, then the whole number is even. I'm going to start by just underlining my hypothesis and circling my conclusion. I'm then going to decide if that's a true statement, and it is. Okay, we're going to write the converse next. All right, here's the converse written out. If a whole number is even, then the whole number is a multiple of 2. And again, multiples of 2, for those of you who've forgotten, would start off with 2, 4, 6, 8, etc. And it says, if a number is even, it's a multiple of 2, and I would have to agree that that's a true statement. So, is this conditional reversible? The answer to that question is yes, and in which case we're going to go ahead and write the biconditional using the hypothesis and the conclusion from this original sentence. All right, go ahead and write that biconditional. So, the biconditional is this statement right here. A whole number is a multiple of 2 if and only if it is an even number. Okay, you may have if and only if the whole number is even. Either one would be perfectly acceptable. Okay, we're moving on to the next example. Rabbits are animals that eat carrots. You'll notice this statement has not been given to you as a conditional. So first thing we're going to do is let's go ahead and see if we can write this as a conditional. Okay, here is our statement as a conditional. If an animal is a rabbit, then the animal eats carrots. And I would have to say that's a true statement. And we're then going to check to see if the converse is also true. So let's write that. Okay, here's our converse. If an animal eats carrots, then the animal is a rabbit. And we can see that, hopefully, you realize that is a false statement. And because that is a false statement, we have to say there is no biconditional possible. Okay, let's go ahead and move on to example 3. In example 3, it's asking you to take the biconditional and rewrite it as the two conditionals. Okay, so in order to do that, the first thing I'm going to do is go ahead and underline the two statements that are going to be the hypothesis and conclusions of the statements I'm going to write. Okay, so we have that, and let's go ahead and write our statements. Okay, so I've taken those two clauses and I've used them both as hypothesis and conclusion in two statements, and you can see the two statements here. And I use different color pen to show where they're each is showing up in the statement. So anyway, hopefully you were able to do that. You do have some leeway in how you expressed it. Notice when I wrote the second one, I had to say if the sum of the measures of two angles is 90, which is a slight change from the original biconditional. So again, be sure to edit as you need so that your sentence is clear to someone reading it. All right, let's move on to the next page. Okay, we're discussing the second objective of Chapter 2, Section 3, which is good definitions. And we can see up at the top, and this is very important, a good definition is these three things. Reversible. It can be written as a biconditional, and it avoids using vague, imprecise, or difficult words. So the example given here is for defining a square, and we goes ahead and walks through the questions based upon the parts of a good definition. So let's go ahead and look at example 1, and we're going to decide if this statement is a good definition. So a triangle is a polygon that has 3 sides, and you'll notice the first thing is it's not written as a conditional statement. So first thing I'm going to have to do is decide if it's reversible, and I'm going to do that by writing it out as conditionals. So let's go ahead and do that. Okay, here are the 2 conditional statements that the original, I chose to use this as the original, and the converse. And both of those statements I would say are true, and therefore, is this reversible? We would have to say, yes, it is. Okay, so now we're going to take those 2 statements and see, can we combine them into a biconditional? Okay, so I wrote out the biconditional. A polygon is a triangle if and only if it has 3 sides. And that seems to work also, so yes, I can write it as a biconditional. And then the third part, is the definition clear and understandable? I think so. So if we answer yes to that, then we have to say this is a good definition of a triangle. Okay, so let's move on to the last example. Okay, here's our last example. We're deciding if this is a good definition for a juice drink. A juice drink is a beverage that contains less than 100% juice. So we're going to go ahead and to explain if it is, we want to go through the 3 steps. The first one being if it's reversible. Let's check. Okay, so I took the juice drink statement and I wrote out 2 conditionals that are converses of each other. And you'll notice the first one, if a beverage is a juice drink, then it contains less than 100% juice. Okay, I'd have to say that's a true statement. I can agree with that. But then the second one says, if a beverage contains less than 100% juice, then it is called a juice drink. Well, here's the thing. I can think of a beverage containing less than 100% juice, and I don't call it a juice drink. For example, what about just plain old water? It contains less than 100% juice, and we don't call it a juice drink. So is this reversible? We have to say no, and then because it is not reversible, we would have to say this is not a good definition for a juice drink. Okay, that is the end of this video, and we'll see you in class. Thanks.